Hello everyone. Today's topic of discussion is Coulomb's law. After explaining Coulomb's law, I am going to take good illustrations related to this law also. See, this law says that if we have two charges, 2 point charges, right? So we should remember this that this law is applicable. It is applicable only for point charges at rest. So let's say I have 2 point charges Q1 and Q2. The separation between the charges is, let's say, R, and as per Coulomb's law, the force of interaction, it may be force of repulsion or force of attraction depending on the nature of given charges. If charges are of same nature, like charges, force of repulsion will be there and force of attraction will be for unlike charges. So the magnitude of force is given by this expression K Q1 Q2, magnitude Q1 Q2, because we are talking about magnitude of this force divided by R square. We also call like this force, this law follows inverse square law because it is following the square of the inverse square relation with the distance, right? Now here let me introduce K. K is some constant which actually explains the medium, behavior of medium, and its value depends on the medium. So K, I must say, that is a proportionality constant, and its value is 9 into 10 raised power 9, and from this formula we can easily write out the unit of K. So I can bring this R square at left and Q1 Q2 at left. So this will be like Newton meter square divided by Coulomb square. So Newton meter square per Coulomb square. Alright, and this value is for air or vacuum. We consider air and vacuum behavior very close to each other, or free space, right? And for any other medium given in the problem, this value of K will be given, right? No need to recall no need to remember all the values of K for all the medium. That is practically not possible. So just try to remember this value only, that is for air, vacuum or free space. Now further, this K is written like this in the form of epsilon. We write K as 1 by 4 pi epsilon naught into Q1 Q2 by R square. Here K has been substituted with this value 1 by 4 pi epsilon naught, and this epsilon naught again is for medium, and it is called as, it is given some name, it is called as absolute electrical permittivity of vacuum or free space, right, or air. And its a value for these things, vacuum, free space or air, is 8.85 into 10 raised power minus 12. And because this is in inverse relation with K, so I can write unit of epsilon naught like reciprocal of the unit of K, Coulomb square per Newton meter square. Alright, so this is all about Coulomb's law. Now let's take few illustrations based on Coulomb's law. Alright, suppose we have two charges, 2 point charges placed at some separation R, and question says that the separation, if the separation between the charges is increased, let's say is increased by, let's say question is increasing this by 300%, then find percentage change, in the value of force, right? In the Coulombian force, we can call it as Coulombian force. Here I'm taking very basic illustrations, and if you want me to give you a good level illustrations, then you will have to wait for next video. In next video I'll be trying to cover a good illustrations related to Coulomb's law. Okay, so here what we are given in the question, the separation has been increased by 300% and we are supposed to find percentage change in the Coulombian force. So we know that force depends on three things, that is medium, another charge and the separation. Here keeping the medium, magnitude of charges fixed, here question is changing R. So let's write first of all the initial force. Let's say these are the values of magnitude of charges Q1, Q2 and separation initially. So initial force will be given by this formula, and further let's write the final distance R, and as per the question the final distance is like it is increased by 300%, so I can write R plus R into 300 by 100. Alright, and this can be further written as 4R. So this is what R dash, right? Now on the final force, therefore the final force I can write, final force is F dash is equal to K Q1 Q2 by R dash square, and this will be like K Q1 Q2, R dash we have got 4R, so 4R square. Now F dash is coming out to be K Q1 Q2 by 16R square. Further it can be written as like F by 16. If we compare this with first equation, let's say this is second equation. Now percentage change in force can be written as percentage change. This is very important because this percentage change thing can be asked from any chapter, from any topic. So I must write percentage change as final force minus initial force divided by initial force multiplied by 100. Now let's substitute the value of F dash, that is F by 16 minus F divided by F into 100. So I am going to get it as minus 1500 by 16%. Right, here minus sign is showing that force is decreasing, right? So whenever you get a percentage change in any quantity negative, that simply shows decrease in the quantity. So this is the very simple profile, simple problem. And in next video I'll be taking, next video is gonna be a little bit lengthy because I'll be taking good illustrations, good profile related to Coulomb's law. You must not skip the next video because next video will be covering frequently asked questions in many competitive exams, right? So if you want to get more such content, good content, then please subscribe the channel if you have not subscribed yet, and stay connected. Thanks for watching.